Welcome. In this lesson, we will understand the decorator design pattern step by step. We begin with inheritance and the point where optional features create too many fixed subclasses. A clothing example will make optional layers intuitive before we use technical details. The same idea will then be applied to a practical notification example without code first. After the idea is clear, readable Java code and a class diagram will connect the design to implementation. We will finish with simple and tricky interview questions. First, we need to understand why inheritance becomes painful. Inheritance is useful when one class is genuinely a stable kind of another class. Suppose the core service needs one optional feature. A dedicated subclass can represent that single choice. A second independent feature needs another subclass when the design relies only on inheritance. When both features are required together, the hierarchy needs a third subclass for that combination. A third option does more than add one class. It creates several new combinations that may each need a type. This growth is called subclass explosion. The hierarchy expands because every useful combination is frozen into a separate class. Inheritance is not the enemy. It remains a good fit for stable ISA relationships. The real problem is forcing every optional combination into a fixed class. We need to keep the core and choose only the needed layers. Think about one person preparing for different weather. The person does not need a different identity for every day. On a cool morning, a sweater may be enough. The choice depends on the current need. For a colder evening, a jacket provides a stronger layer without changing the person. When rain is the concern, a raincoat handles that requirement, while the same person remains underneath. Some days need a sweater and a jacket together. The layers can be combined. Another day may need a jacket and a raincoat. The combination changes with the situation. Across every choice, the person remains the same. Only the selected layers change. That is the useful intuition. Choose only the layers required right now rather than defining every possible outfit in advance. In software, this kind of selectable addition is optional behavior. The core stays stable while the surrounding choices vary. The clothing example gives us intuition, but the technical idea needs its proper name and boundary. At the center is an existing core object. Its main identity and responsibility remain unchanged. Optional behavior can sit around that core, so a requirement can select only the additions it needs. This is the decorator design pattern. It adds optional behavior around an existing object without creating a subclass for every combination. Inheritance still fits stable ISA relationships. Decorator fits behavior that is optional and needs flexible combinations. Next, this same core and layers picture will guide a notification example using email, SMS and Slack without code yet. The same core and layers idea becomes concrete when the core responsibility is an email notification. Email is the core notification because it can complete the basic responsibility by itself. The empty positions matter because additional channels are choices, not requirements for the email core to work. Its core behavior is simply to send the email without assuming SMS, Slack, or any other channel. An email-only notification is already complete, so every later channel must remain optional. Because the email core stays unchanged, the first extra channel can be added as a separate layer. This notification model keeps one email core and treats every extra channel as an independent choice. The SMS layer adds a second delivery channel while leaving the email responsibility unchanged. With this choice, the notification keeps email and adds SMS as an extra responsibility. Removing the SMS choice does not break the notification because email remains a complete core behavior. The Slack layer adds a workspace notification without changing what the email core already does. This configuration keeps the same email core but selects Slack as the additional channel. SMS and Slack remain separate reusable choices, so neither channel becomes permanently built into email. The important rule is independence. The core stays stable, while each optional layer can be selected separately. There are two ways to model these choices: create a fixed class for each combination or reuse optional behavior layers. The subclass approach starts by creating one fixed class for the email and SMS combination. A different choice needs another fixed class, even though most of the notification behavior is similar. Selecting both optional channels produces a third fixed class, and more choices would keep increasing the count. This growth is subclass explosion. every new optional choice creates more fixed combinations to maintain. The decorator approach keeps one email core instead of creating a new core class for each combination. The SMS decorator remains one reusable behavior layer that can be selected for any suitable notification. The Slack decorator follows the same idea, adding another reusable choice without defining a new fixed combination. Reusable decorators solve the growth problem because the system chooses behavior layers at runtime instead of defining every combination in advance. The notification example reduces to one practical rule for using the decorator design pattern. First, keep a core object that already provides the essential behavior. Second, add reusable behavior layers only when the current notification needs them. Third, choose the required combination at runtime rather than defining it permanently in a subclass. Email alone remains a valid runtime choice because the core behavior is already complete. Email plus SMS uses the same core and one selected reusable layer. Email plus SMS plus Slack uses the same reusable pieces without needing a dedicated combination subclass. These same notification pieces can next be mapped to Java roles without changing the mental model. The no-code stack already has a core and optional layers. Java now gives each role a precise type. Notifier is the shared contract. A core object or decorator can be used wherever a notifier is expected. The interface declares one send operation. That small contract makes every layer interchangeable. Email notifier is the concrete core. It sends email even when no optional decorator is present. Because email notifier implements notifier, client code can depend on the contract instead of one concrete class. Its send method performs the basic email action. This behavior remains available after decorators are added. The first mapping is complete. Notifier defines the common shape, and email notifier supplies the core behavior. Base decorator is the reusable middle layer. It follows the notifier contract while holding another notifier inside. The abstract base decorator implements notifier, so every concrete decorator keeps the same external contract. This field means the decorator contains another notifier. That object relationship is composition. The constructor receives the notifier. This decorator will wrap. The concrete type can vary at runtime. The assignment stores that reference, allowing later calls to continue through the wrapped object. Because base decorator is still a notifier, clients call the same send operation they already know. Delegation means base decorator passes the original call to the wrapped notifier, instead of replacing its behavior. Base decorator holds a compatible object, receives it through the constructor, and delegates before focused behavior is added. Concrete decorators share one pattern. Preserve the existing notification, then add one focused channel behavior. SMS decorator extends base decorator, so it inherits the wrapped notifier and shared delegation behavior. Calling the base send method lets the existing notification work continue through the wrapped chain. After preserving the existing behavior, SMS decorator adds its own SMS responsibility. Slack decorator follows the same contract and base mechanism, only the channel-specific responsibility changes. Slack decorator first preserves the wrapped notification, then adds the Slack action as its focus responsibility. Both decorators remain notifiers, both delegate, and each adds one responsibility. That shared structure makes the layers reusable. Main does not need a class for every channel combination. It assembles compatible notifier objects at runtime. For email only, main creates email notifier directly. No decorator is required when no optional channel is needed. The variable type remains notifier, while the actual object is the concrete email core. For email plus SMS, main wraps email notifier with SMS decorator. The outer object still satisfies notifier. The call enters SMS decorator, continues to email notifier, and completes both email and SMS behavior. For all three channels, Slack decorator wraps SMS decorator, and SMS decorator wraps email notifier. Every object in the chain follows notifier. The stack changes behavior without creating a fixed subclass for this combination. This implementation now gives us a concrete basis for explaining decorator clearly in an interview. What problem does the decorator design pattern solve, and when should you use it? Decorator avoids subclass explosion by wrapping a compatible object and adding optional behavior through composition. The problem is subclass explosion. each optional combination can become another fixed class to maintain. The solution uses composition, so a decorator contains a compatible object, preserves its contract, and adds focus behavior. Decorator fits when responsibilities are optional, composable, and likely to vary at runtime. Decorator is not always better than inheritance, because inheritance still fits stable is a relationships. A strong interview answer stays structured. Name the problem, explain the composition-based solution, and finish with the fit condition. That structure keeps the answer precise and prevents the common mistake of treating decorator as a universal replacement for inheritance. How is decorator different from inheritance and from an ordinary wrapper? Inheritance fits table is a relationships, while decorator uses composition for optional behavior that can vary at runtime. Inheritance is a good fit when the relationship is stable and the subtype genuinely represents an ISA relationship. Decorator is a good fit when compatible objects need optional responsibilities that can be combined at runtime. Wrapper is a broad mechanism word, while the decorator design pattern adds the specific intent of extending behavior compatibly. Java I/O streams are a classic decorator family because compatible stream objects can add focused behavior around another stream. Collections wrappers provide another familiar recognition point because one collection can be wrapped with an additional policy or behavior. Not every wrapper is a decorator. The pattern preserves a compatible contract and adds a focused responsibility through composition. The interview decision rule is simple. Use inheritance for a stable type relationship and decorator for optional composable behavior. The decorator design pattern adds optional behavior by wrapping a compatible object instead of creating every combination as a subclass. First, check whether you can explain why optional combinations create subclass explosion. Second, check whether you can explain how composition keeps one core and adds reusable behavior layers. Third, check whether you can map the component, decorators, delegation and runtime stacking to the Java example. If you can explain these 3 points clearly, you can give a focused interview answer without reciting the whole implementation. Remember the core idea. Compatible wrapping adds optional behavior without a subclass for every combination.